quick, what's the pH of hydrochloric acid? Well, to find that out, you need to know the molarity. So let's say I give you a very small molarity. What if I say it's 1 times 10 to the negative 8th molar? Now, usually when you use a formula to find the pH of something, you're just going to go and plug it in. You're going to find the concentration of hydronium ions. Over here, that's going to be 1 times 10 to the negative 8th. And you take the negative log of that. So that's negative log of 1 times 10 to the negative 8th. That's negative times negative 8, which is 8. But there's obviously something wrong there because 8 is above 7, which means it's basic, even though hydrochloric acid is a very, very strong acid. So what's the problem over here? Well, the issue over here is that because of what a small rate there is of, because of the very, very small concentration or molarity of hydrochloric acid, there's another factor at play over here that's producing hydronium ions. And it's not just going to be the hydrochloric acid anymore, because remember, hydrochloric acid, to be an acid, it's in an aqueous solution, right? And when it's in that aqueous solution, because of how small that is, we also have to consider the water, which is also going to be producing hydronium ions. Now, why would this be? Well, think about water. Water is H2O, right? So it actually functions as both an acid and a base in a sense, because it can take hydronium ions, it can accept them, but it can be a proton donor, a proton acceptor, which is a base, but it can also be a proton donor, which is an acid. And both of them are at play over here. And because of just how little hydrochloric acid there is, you have to include this as well. Now, when you're actually doing this in chemical questions, usually it isn't too big of a deal. You can set up a few different equations, and once you simplify them, there are some formulas that aren't too difficult. It's like a little quadratic thing. Now, the other problem is when you're dealing with a very, very weak acid, right? Now, hydrochloric acid, which we mentioned over here, is a very strong acid. But what if we had something much weaker? Now, over there, this is going to be doubly important because already there's so little there's such little protonation going on because of the weak acid, and it's in very low concentration. So we have to use this, but it becomes an even more complicated equation, often going into cubics, right? And you can't really solve a cubic by hand. So for that, you end up needing computers or like some sort of mathematical software. But hopefully, in case you ever thought that, because I know I've wondered that before, and I'm glad I found out today, so I hope you learned something new as well.